Hello and welcome to another college math video. In this video, we're going to look at conditional probability. This is a probability question where we have a little bit more information. So our objectives: look at vocab and concepts related to conditional probability, calculate conditional probability, and solve applications involving conditional probability. Our notes: what is conditional probability? The formal definition is a little bit clunky, and even the formula is a little bit clunky, so we'll talk about it in a more condensed way, I would say. But let's get the formal stuff down first. Conditional probability, the probability of E2 occurring, this is based off of this formula, given that event E1 has happened. And that's exactly what the formula says. E2, this line means given, E1. You'll see it that way in an online system, and if you were looking kind of across the discipline, you would see it written that way. It's not typically the way that I'm going to write it down, but just so you know, that's what it would look like. The key word in all of this is given. I cannot stress enough how important this word given is. This is what indicates to you that you have more information, and so you're not necessarily looking at the entire picture. Again, the translation of this formula, probability of E2 given E1, or the number of E1 and E2 over number of E1. This formula does work, but it's really clunky and I'm not really a fan of it. The given, let's add a couple more notes here and then we'll just start to look at some examples and go through them a little bit more simplistically. And trust me, I'm not the only person doing it this way. If you looked at other videos or were in another class, most likely you were taught this other way, not necessarily using the formula. But this is important. The given is so important. You see the word given and you know, okay, this is the type of problem I have. But whatever the given piece of information is, given blah, 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 that's your denominator. It tells you the denominator. This all sounds scary, but it'll be better once we start to see some examples. The other thing that I want to suggest to you is that you focus on the denominator first. We have been doing that, and part of the reason we've been doing that so exclusively, or making that our focus first, and then coming up with numerator, is that once you're in conditional probability, you're already conditioned to do that. So focus on the denominator first. So if you see any problem, even if it starts with the word given blah, 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 what's the probability of X? You know it's this type of problem. The given tells you the denominator, and then we do the same thing. Of those, however many in the denominator, how many fit your criteria? So our analysis won't really look too different. All right, so what does it look like? A card is chosen randomly from the standard deck of cards. Again, if you don't know what that looks like, you can pull up this deck on another page. On a test, you would need to know it. Find the probability that a card chosen is a queen given that the card is a face card. There's the word given. This tells us. The alarm bells go off. We know this is a different type of problem. So we still are looking for, in this case, the event is that the card is a queen. We're looking for the probability of queen. But it's given that the card is a face card. We have more information. If we didn't have the given, if the last part of the problem wasn't there, find the probability that the card chosen is a queen. We would say there's 52 cards in the deck. Of those 52, how many are queens? 4 out of 52. Simplify. But here we know something else. You can imagine the deck of cards is in front of you. One gets pulled up. You don't see it yet, and the person tells you, you want a queen. They tell you, well, it's a face card. A face card means that it's a jack, queen, or king. So if they say, given it's a face card, the whole deck is sitting there, but they tell you, this card's a face card. You don't actually have the whole deck of cards to consider. All 52 aren't options anymore. It's only the cards that are face cards. So your denominator, the given, is your denominator. Tells you denominator. The card is a face card. So there are 4 queens, there are 4 kings, there are 4 jacks. So there are 12 face cards. Of those 12 face cards, how many are what you want, which is a queen? 4. Sometimes it's there are 4 cards, 4 queens in the deck. Sometimes it's the same number. You just have to do it problem by problem. So same line of thinking. Of the 12, how many meet the criteria we want, which is queen, and it's 4 of 12. So this simplifies to 1/3. The given is everything. You see the word given, you know, oh, the question was standard deck of cards. In your mind, you're probably thinking 52. But if they say, given that it's a face card, the whole deck doesn't exist anymore. It's just the face cards. There's only 12 options in this case. Of the 12, how many met the criteria? 4. 4 of 12, simplify, 1/3. And that's what every conditional problem looks like. It's conditional because you're given an additional piece of information. All right. Let's say we have a bag with 10 red, 5 yellow, 8 green, and 12 purple chips. So the bag total has 10, 5 is 15, and then the 8 and the 12 is 20, so 35 total. All right, find the probability of choosing a red given it's a primary color. So the chips are all in there. One is picked. You're hoping for red. You can't see it. The person tells you, oh, it's a primary color. That means you're closer. All 35 aren't an option anymore. We're still looking for probability of red, but all 35 aren't options anymore. Now it's just the primary colors, given primary color. What are the primary colors? Well, if you don't remember, primary colors are red, yellow, and blue. You would never be asked a question on a test where I would expect you to know something like primary color. Maybe you remember, maybe not. During a sort of in-class video thing like this, we can discuss it. So don't worry that that's something you'd be expected to know. Red, yellow, and blue are primary colors. So the only ones that are options, if they tell you, well, it's a primary color, are the red and yellow, because we don't have blue chips. So your denominator is 15. Of those 15, how many meet your criteria of being red? Of the 15, there are 10 that are red. 10 out of 15, simplify. 2/3. Okay, next one. Find the probability of choosing purple given it's not yellow. Probability of choosing purple, purple's the event, given it's not yellow. So it's not all 35 as the denominator, it's not yellow, which means it's red, green, or purple. You're hoping for purple, they pick the card or the chip and then they say, well, it's not yellow, which means you're closer. You don't have all 35 to consider anymore. It's not yellow, so that's gone. There's only 30 left. Of the 30, how many meet your criteria of being purple? There are 12 in the bag. So 12 out of 30, which simplifies to 2/5. Okay, next one. Find the probability of choosing a green given that it's green or red. Probability of choosing green, so green is the event. Given that it's green or red. So they pick the chip. All 35 are in the bag, but they tell you, well, it's either green or red. You're hoping for green. They tell you it's green or red. That narrows it down. You know that it's not the red, and you know that it's not the yellow. So it's either, green or red. You know it's not the yellow, you know it's not the purple. Green or red. So how many options do you have? 10 plus the 8, 18. Of the 18, how many fit your criteria of being green? Of the 18, there are 8 that are green. This simplifies to 4/9. One more. Given the chip is a warm color, what's the probability of choosing a red? Red is the event. Probability of choosing a red. Just because the given's in front doesn't change anything. Given tells you denominator, what's the probability of, and then your event. So we want probability of red. Given the chip is a warm color, this tells us denominator. Again, I would never expect you to remember what a warm color is. The warm colors are yellow, orange, and red. So if they say, well, it's definitely a warm color, then you know it's either the yellow or the red. So there's 15 options. Of the 15, how many meet your criteria of being red? 10 of them. 2/3. Good. I can't stress enough how important the given is. Start with the given, get your denominator, and then assess based on the denominator what the numerator should be. And I would suggest that on every problem, every probability problem. Okay, so let's do some practice in this realm. In this case, there are desserts behind the counter: 6 strawberry, 4 chocolate, 3 vanilla, and 2 peach. You tell the worker to choose one randomly for you. You can picture this happening, and then maybe you say to the person behind the counter, in the first scenario, probability of it being peach given that it has fruit. So you say, you know what, just pick one. But then you go, but I really like fruit. Then they might pick something with fruit, so you're wondering what the probability of peach is. So go ahead, pause the video, run through these 3 scenarios based on those premises, and we will see if things match up. Okay, so our first problem, probability of peach given the dessert has fruit in it. So we're looking for peach as the event given the dessert has fruit in it. 6 strawberry, 4 chocolate, 3 vanilla, 2 peach. So how many have fruit in it? The 6 strawberry and the 2 peach. So out of those 8, how many meet your criteria of being a peach dessert? 2. 2 out of 8 simplifies to 1/4. All right, next one. Find the probability of a vanilla dessert being chosen given that there are 3 or more of the dessert available. So in this case, you're telling the person behind the counter, you know what, you just pick. You pick whatever you think would be good. Well, if you're the person behind the counter, you're probably not going to pick the one that only has a couple left because you want more options for later customers. So you pick one that has 3 or more of the dessert remaining, which means you're either picking strawberry, chocolate, or vanilla. So 6 plus 4 plus 3, there are 13 options. We want probability of vanilla. Of those 13, how many meet the criteria of being vanilla? 3 of the 13. And it doesn't simplify, so that's it. And then the last question, given the dessert is not made of fruit, what's the probability that it's chocolate? So you say, pick one for me, but I don't really like fruit. So then they're gonna go either chocolate or vanilla. What's the probability that it's chocolate? The given tells you denominator, not made of fruit, which means it's chocolate or vanilla. So there are 7 options. Of the 7, how many meet the criteria of being chocolate? 4 of the 7. And that's where it simplifies. All right. One more practice problem. This one is a little bit different. Your information is in a chart form. We have information on if the Easy Pass was used or not, and for what type of vehicle rental. All right, so for all of these cases, one vehicle is chosen randomly from the study for further questioning. So go ahead, pause the video, run through these 2, and we'll see if we're on the same page. Okay, first question, find the probability the Easy Pass was not used in the vehicle. There's no given in this question, which means everyone from the whole study is a part of things. So probability Easy Pass not used. We'll call it circle with slash. No given, so everyone counts. Out of the full 2,461 people in the study, how many did not use the Easy Pass? This is the not used row. 935 were cars, 683 were trucks, for a total of 1,618. So 1,618 of the 2,461. And I don't think this simplifies, so that should be it. Okay, second one, find the probability the selected vehicle was a truck. No given, again, it's just a standard probability question. I threw a few of them in there to make sure you understand the difference. We're looking for probability of truck. There's no given, so everyone is a part of the study out of the 2,461. 461, one name is one name is chosen randomly. Out of that 2,461, how many are trucks? That's this column. 316 did use it, 683 did not, for a total of 999. And again, doesn't simplify. All right, third question. Find the probability the E-ZPass was not used given it was a car. We're looking for E-ZPass not used, but we have a given it's a car. So we want probability of not used given it's a car. How many cars were there in the study? These are our cars. There were 1,462 cars. Of those 1,462, only of those, the given focuses in on this. Not everyone counts anymore. We only care about cars. How many of those did not use the E-ZPass? 935, which simplifies to 55 over 86. I'm breezing through the simplifying because your calculator can do it. I'm not expecting you to do that by hand. Okay, and then the last one, find the probability of the vehicle being a truck given the E-ZPass was used. Find the probability, let's go with a different color. The vehicle being a truck given E-ZPass not used. So we want probability of truck given E-ZPass was used. So how many used the E-ZPass? That's this row right here. So we only care about these now. There were a total of 843 that used it. Of those 843, how many are a truck? 316. And it doesn't seem to simplify. So that looks like everything. There's not really a lot of room for variation in conditional problems. The big change potentially could be that the given portion is written first in the sentence and the find the probability of XYZ is written second. That's really all that could happen, and we've seen that throughout this video. So again, the main thing to keep in mind with conditional probability is to always, always, always start with the given, which is your denominator, and then from the denominator, come up with how many meet your criteria to be in the numerator. All right, I'll see you soon for another video.